So now we will discuss the summary of Chapter 11. Chapter 11 is entitled Build a Small Network. Up to this point of the course, we have considered the services that a data network can provide to the human network, examined the features of each layer of the OSI model and the operations of TCP or IP protocols, and look in the detail at Internet, a universal LAN technology. The next step is to learn how to assemble these elements together in a functioning network that can be maintained. Small network topologies. The majority of businesses are small. It is not surprising then that the majority of networks are also small. A typical small business network is like that. With small networks, the design of the network is usually simple. The number and type of devices included are significantly reduced compared to that of a larger network. The network topologies typically involve a single router and one or more switches. Small networks may also have wireless access points or the possibility built into the router and IP phones. As for connection to the internet, normally a small network has a single one connection provided by DSL, cable, or an Ethernet connection. Managing a small network requires many of the same skills as those required for managing a larger one. The majority of work is focused on maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. The management of a small network is either done by an employee of the company or a person contracted by the company, depending on the size and type of the business. So, device selection for a smaller network. In order to meet user requirements, even small networks require planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. When implementing a small network, one of the first design considerations is the type of intermediate device to use to support the network. When selecting the type of intermediate devices, there are a number of factors that need to be considered. So first, cost. The cost of a switch or router is determined by its capacity and features. The device capacity includes the number of types of ports available in the backplane speed. Other factors that impact the cost are network management capabilities, embedded security technologies, and optional advanced switching technologies. The expenses of cable runs required to connect every device on the network must also be considered. Another key element affecting cost consideration is the amount of redundancy to incorporate into the network. Speed and types of ports interfaces. Choosing the number of type of ports on a router on switch is a critical decision. Newer computers have built-in 1 GB NICs. 10 GB ports are already included with some workstations and servers. While it is more expensive, choosing layer 2 devices can accommodate increased speeds, allow the networks to evolve without replacing central devices. Expandability. Networking devices come in both fixed and modular physical configurations. Fixed configurations have a specific number and type of ports or interfaces. Modular devices have expansion slots that provide the flexibility to add new modules as requirements evolve. Switches are available in additional ports for high speed and uplinks. Routers can be used to connect different types of networks. Care must be taken to select the appropriate modules and interfaces for the specific data. Operating system features and services. Depending on the version of the operating system, a network device can support certain features and devices and services such as first, security. Second is the quality of service or the QoS. Second is the voice over IP or the VoIP. Next is layer 3 switching. Next is network addressing translation or the NAT, and the dynamic host configuration protocol or the DHCP. Redundancy in a small network. Another important part of networking design is reliability. Even small businesses often rely heavily on a network for business operation. A failure of the network can be very costly. In order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps to eliminate single points of failure. There are many ways to accomplish redundancy in a network. Redundancy can be accomplished by installing duplicate equipment, but it can also be accomplished by supplying duplicate network link for critical areas. Small networks typically provide a single exit point toward the internet via one or more default gateways. If the router fails, the entire network loses connectivity to the internet. For this reason, it may be advisable for a small business to pay for a second service provider as backup. So, Chapter 11, Build a Small Network. In order to meet user requirements, even small networks require planning and design. Planning ensures that all requirements, cost factors, and deployment options are given due consideration. An important part of network design is reliability, scalability, and availability. Supporting and growing a small network requires being familiar with the protocols and network application running over the network. Protocol analyzers enable a network professional to quickly compile statistically information about traffic flows on a network. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic as well as the type of traffic being sent. This analysis can be used by a network technician to make decisions on how to manage the traffic more efficiently. Common network protocols include DNS, Telnet, SMTP, POP, DHCP, HTTP, and FTP. It is necessity to consider security threats and vulnerabilities when planning in network implementations. All network devices must be secured. This includes routers, switches, end users, devices, and even security devices. Networks can be protected from malicious software such as viruses, Trojan horse, and worms. Antivirus software can detect most viruses and many Trojan horses applications to prevent them from spreading in the network. The most effective way to mitigate a worm attack is to download security updates from the operating system vendor and patch all vulnerable systems. Networks must also be protected from network attacks. Network attacks can be classified into three major categories: the reconnaissance, access attacks, and denial of service. There are several ways to protect a network from attacks. First is authentication, authorization, and accounting, or AAA or AAA. Network security services provide the primary framework to set up access control on a network device. Next is a firewall is one of the most effective security tools available for protecting internal network users from external threats. Next is to protect network devices. It is important to use strong passwords. Also, when accessing network devices remotely, it is highly recommended to enable SSH instead of the unsecured telnet. After the network has been implemented, a network administrator must be able to monitor and maintain network connectivity. There are several commands available towards this end. For testing network connectivity to local and remote destination, commands such as ping, telnet, and traceroute are commonly used. On Cisco iOS devices, the shown version command can be used to verify and troubleshoot some of the basic hardware and software components used during the boot process. To view information for all network interfaces on a router, the show IP interface command is used. The show IP interface brief can also be used to view a more abbreviated output than the show IP interface command. Cisco Discovery Protocol, or the CDP, is Cisco proprietary protocol that runs at the data link layer. Because CDP operates at the data link layer, two or more Cisco network devices such as router that support different network layer protocols can learn about each other even if layer 3 connectivity does not exist. Cisco iOS configuration files such as startup config or running config should be archived. These files can be saved to a text file or stored to a TFTP servers. Some models of routers also have USB port, and file can be backed up to a USB drive. If needed, these files can be copied to a router and a switch from the TFP server or USB drive. So that's all for all the chapter summary from chapter 1 to 11. I hope you learned a lot, and good luck to you. And that's all for the summary of chapter 11. I hope you guys learned a lot from me.